Hello, and welcome to this tutorial on FX Forwards, Part 2. This tutorial picks up where the previous tutorial on FX Forwards left off, where we saw that a FX Forward price or transaction could be replicated by other transactions. Here we'll look at how the transactions replicating an FX Forward and the FX Forward itself could create a potential arbitrage opportunity, and we'll introduce the formal concept of covered interest rate parity. We'll also look at how we can synthetically create a borrowing or lending using the same relationship. And finally, we'll introduce the concept of non-deliverable forwards, which will apply these same concepts to non-convertible currencies. So let's start with a review, replicating an FX forward rate. So we want to replicate buying Euro US dollars forward. So we're going to be paying US dollars in 1 year and receiving euros in 1 year. So the transaction to do that is, well, we want to borrow US dollars so that in 1 year we will be paying out the US dollars. So that's US dollars in today. So we'll get US dollars in today, we'll pay them in 1 year. So that's shown right here. Then the US dollars that we have today are used to buy euros today at the spot exchange rate. And then those are invested and give rise to euros in 1 year. So what you see here is we have an outflow of US dollars in 1 year, an inflow offset by an outflow. So an inflow from the borrowing, and then the outflow is the exchange. The inflow of euros is the exchange, and then the outflow is the investment. And then we end up with receiving the return on investment, principal plus interest in 1 year, so that's inflow. So here everything cancels. The euros in and out cancel, the US dollars in and out cancel. We're left with the same payout that we would have with an FX forward, and that's why this is a replication. So if we look at this in numbers, remember we came up with this exchange rate before. So let's say our FX forward is $1.2119 per euro. Okay, so we're going to borrow, do a borrowing where we end up paying $1.2119 in 1 year. And if the US dollar interest rate is 2%, that means that we will essentially borrow this amount, 1.1881, add 2% to that, and that's what we'll have to pay back. This 1.881 that we borrowed will be exchanged at the spot rate of 1.2, and that's going to give us 0.9901. So it's this figure divided by the spot rate to get us euros. And this 0.9901 euros is invested at 1%, and it gives us 1 euro. So essentially, we've replicated here 1 euro for $1.2119. And this transaction can go, if we don't have no for spread, it can go in exactly the opposite direction. We can borrow euros, end up with this many today, sell euros at the spot rate, end up with this number of dollars, invest at 2%. So the transaction can go either way. And that would then be replicating selling euros, dollars forward. Okay, so let's consider another problem. What is the replicated rate for dollar peso 1 year forward given the dollar Mexican spot rate of 18.5 and a dollar 1 year rate of 2% and the Mexican 1 year rate of 7%? All right, so we want $1 in 1 year. So how many dollars would we have to invest today? Well, we take this 1 divided by 1.02, so we would need to invest 0.9804. So that's the amount of dollars we would need to invest at 2% to end up with $1 in a year. So where would we get 0.9804? Well, we would get it in the exchange market from Mexican pesos. So we're going to buy dollars at 18.5. So how many pesos do we need to buy this many dollars? Well, 18.137 pesos divided by 18.5 would give us this number of dollars. Okay. And then where do we get our pesos? Well, we're going to borrow the pesos. So we're going to borrow 18.137 pesos. The interest rate is 7%. So borrowing this many pesos at 7% means we're going to need to pay 19.407 in pesos. So the net effect is we're going to pay 19.407 pesos for $1. Okay. And that's the replicated forward rate. So let's formalize this. What we've been doing at the end of the last tutorial and at the beginning of this one is covered interest rate parity. So covered interest rate parity relates the interest rates on two currencies to the spot and forward FX rates, and notes that an FX forward can be replicated by borrowing on one currency, exchanging at spot, and investing at the other. And that's exactly what we were doing. Similar to forward interest rates, forward FX rates are not necessarily an unbiased predictor of the future spot FX rates. So we're not saying the spot, we're not saying that the forward is the expected spot FX rate, but it is today's price for a future FX rate. So think of it in that way. So let's think about covered interest rate parity arbitrage. And arbitrage is really what is the enforcing mechanism, the market enforcing mechanism that will drive these forward rates to be what we were just observing. So suppose you can borrow 1 year in euros at 1% and invest for 1 year in dollars at 2%. If the spot euro dollar rate is 1.2 and the 1 year forward euro US dollar FX rate is 1.21, is there an arbitrage? So notice we have four things quoted here. 1 year euro rate, interest rate at 1%, 1 year US dollar interest rate at 2%. We've got a spot exchange rate and we've got a forward exchange rate. Now we just saw that if we had the first three, that implied the fourth. But what if the fourth is trading in the market as well? So there's a potential arbitrage if this number is not consistent with what can be replicated with ease. So this is the series of transactions we would need to do to determine whether there was an arbitrage profit. So step one, we borrow 100 euros for 1 year. So that means we're going to borrow 100 euros. So we're going to have a plus 100 euro cash flow today. And since the interest rate is 1%, we have a negative 101, a cash outflow of 101 euros in 1 year. Okay, so we have 100 euros today. We're going to sell the 100 euros at the spot in the spot FX market for $4 at this rate, 1.2. So that means we're going to have an outflow of 100 euros and we're going to have an inflow of $120. And then we're going to invest that $120 at the interest rate of 2%. So an outflow of $120 today, and we're going to get 122.40, which is 120 times 1.02, so reflecting the interest. So we notice that today everything cancels out. The euro inflows and outflows cancel out, the dollar inflows and outflows cancel out, so we're left with 0. In 1 year, the euro cash flows cancel out, so there's no euro cash flows. 101 goes out, 101 comes in. But now notice this, we did this forward transaction. So the forward rate's 1.21. So we're going to, basically we need an inflow of 101 euros, and we're going to do that at this exchange rate of 121. So we're going to buy euros forward at that exchange rate. And so that means we're going to have to pay 122.21. But we have 122.40 coming in. So we actually have an extra 19 cents. So the question, is there an arbitrage? Well, it looks like there is. And the only caveat we should raise is, are there any risks associated with it? So let's go back to our box diagrams and see how this works. So this is the same trade that we just did. We have 100 euros today. That we borrowed it at 1%. So we're going to have 101 going out in a year. We're doing the spot exchange rate at 120. that's going to be invested at 2%, and we're going to have 122.40 in 1 year. And then we're going to do the forward rate here. 122.21 is going to be the amount that we're going to have to pay in dollars to buy 101 euros. So we're going to buy 101 euros at 1.21. And since that is 19 cents less than we need, we actually can take 19 cents out of the machine. So you can think of this as a machine that's sort of generating 19 cents every time you run it through. And the question is, how long would we do this? Well, if there were no risks to any of these transactions, then do it forever, and that would tend to drive the prices together. The one caveat we'll raise is that there are potential counterparty risks on the FX forward trade and on the US dollar investment. So you've invested here at 2%. If that's risk-free, then you're okay. And if this FX forward trade is also risk-free, then you're okay. And this is an arbitrage profit. To the extent that there's any counterparty risks on that, you may look at this 19-cent profit as compensation for bearing that risk. So that's the relationship, and there are two versions of it that you should be aware of. One is the bond rate version, and then we'll look at the money market version. And the bond rate version says we have a base currency with value of 1 times 0. We have the spot exchange rate here, which we're going to note as the base currency to the quoting currency. So we're using our nomenclature for that. We have the relationship with today in the base currency and the future. So 1 of currency of the base currency is equivalent to 1 plus RBT. So this is the base currency at time t compounded for t periods. And then similarly in the quote currency, the same thing. SBQ, so this is the base currency quoted because that's the amount that we would be investing or borrowing. This is the interest rate. So the equivalent amount in time t would be here. And so the forward FX rate, FBQ T, so this is the base currency to quote, at time t would be given by this relationship. And that is such that this must equal that, okay? And that will only be the case if SBQ is times this amount divided by this is equal to the forward rate. So if the forward rate is given by this relationship, then we would have no arbitrage. And I should note these are effective annual rates, so if we're doing frequency, we would have to make an adjustment for that. Now, there's a money market version of this, and it's really the same thing that we've been doing, but it is a little more intimidating because we're using formulas. So 1 of the base currency at day D, so this could be, think of this 30 days in the future, will have a value of 1 plus number of days. And here we're assuming the days in year convention is 360, but if it's something else, you would use where that is for that base currency. And then the interest rate on a simple interest basis for that currency. And then similarly for the quote currency, we're doing the same thing, but the amount that's invested or borrowed is given by the spot rate. And so we will end up with this amount on day D. And so basically the ratio of these two must be the forward rate. So SBQ, so this amount divided by this, has to be the forward rate to avoid the arbitrage. Now there are implications of interest rate parity. And an important thing to note is that that if we have 3 of the legs, we actually can imply the 4th. So if the FX forward rate is going to be a premium or discount to the spot rate, it's going to be based on the interest rate differential between the quote and the base currencies. So euro and US dollars in the example we've been looking at. So if the interest rate in the quote currency is higher than in the base currency, the forward FX rate will be higher. So just to make this a little clearer with an illustration, if the US dollar quote rate was 2% and the euro interest rate was 1%, that difference will imply that the forward euro US dollar rate would be higher than the spot. And that's what we saw in our examples, that it went from 1.2 to 1.2119. And that's because dollar interest rates were higher than euro interest rates. If they had been the same, so if these two rates, RQ2 and QB2, were the same, this would all become one and the forward rate would equal the spot rate. So if the quote rate is higher, which it was in our example, than the base rate, then the forward rate will be at a premium to the spot rate or higher. And that premium, we can also look at that in pips. So pips being this part here, 119 pips that you may remember from the conventions tutorial. Now, what this means also is that we can rearrange the formula to get the interest rate. So if we have this relationship, the forward rate is given by the spot rate, and then dependent on the interest rate differential between the quoted and base currencies. Actually, if we have this and we have this and we have one of the interest rates, it implies the other interest rate. So if we have the quote currency and we want to know what the base currency rate would be, it would be given by this formula, and this is just simply a rearrangement of that one to solve for RBT, and then this is the same thing and in terms of the quote currency. So if we go back to our example, if we had euro interest rates or dollar interest rates, so dollars were the quote currency of 2%, that would be 1.02. This would be our spot exchange rate. This would be our forward exchange rate minus 1. The 1 over t doesn't matter here because it's one period. And we'll get our 1% back. And if we were to look for the implied dollar rate based on the other three variables, we'll see we get 2% back. So all this is doing is saying that if you have three of the variables, the fourth one is implied. And this can be used if you're given the forward rate and a liquid market and forward contracts rate and one of the interest rates, there's an implied interest rate in the other currency that you don't have. So let's look at how this would play out with our box diagrams. Suppose you can invest for 1 year in dollars at 2%, and you can buy euro dollars forward at 1.21. Are you able to indirectly earn a 1-year spot rate in euros? What will we do? Well, we take our 100 euros, we exchange it for dollars. So we get $120. We invest that at 2%. And at 2%, we'll end up with 122.40. We would have done this today, done the forward exchange or bought basically euros forward at 1.21 per dollar, per euro. So we would be selling, we'd be selling dollars forward for euros. And so we would get 101.16 euros in 1 year. All right. And what interest rate would that imply? Well, we started with 100 euros and we didn't invest at all. We invested it in dollars, and then we sold our dollars for euro at the forward exchange rate, and we ended up with 101.16 euros. So the implied euro rate is 1.16%. Okay. So now let's extend this to even further. So in an FX spot trade, the parties want to exchange currencies, take delivery. And with FX forwards, this may not be desirable. So in some cases, you just want the exposure. So the motivation for trading FX forward may only be to have the economic exposure to changing FX rates, for example, to do a hedge of another position, or maybe to speculate. So you're not actually looking to take delivery. Forwards and futures may be cashed out ahead of settlement to realize gains or losses while avoiding delivery. And that's actually very common in the futures market, which is used really to hedge the movements in rates rather than to actually take delivery of the currency. And so in that case, they would be canceled out. There's actually another product called non-deliverable forwards that actually specify a net cash settlement. So you don't even have the option of taking delivery. They are cashed out according to the market prices. And so for non-deliverable currencies, non-convertible currencies, the NDFs may be the only option for doing this. So let's look at them. Non-deliverable forward is a forward FX contract settled in an international currency, for example, US dollars. There's no delivery of currencies as with a normal FX forward. So the NDFs enable taking a position synthetically currency that is not internationally convertible. The NDFs can be used for hedging spot rate changes or to create a synthetic investment in the NDF currency. So like what we were doing before, where we were looking at what the implied interest rate would be in a currency based on the forwards and the spot rate and one interest rates, we could do that with NDFs. And another thing that can be done is government issuers or others can issue an offshore bond where the payments are indexed to the local currency, but they're paid in dollars. This allows them, in effect, to borrow internationally in local currency without making the currency convertible. And that's been done by a number of countries. So how does this work? So deliverable forward, there's actually exchange. So with a deliverable forward, party A agrees to pay in 91 days $100 to party B in exchange, and this is a made-up currency, RTR, and we're going to say the exchange rate was 20 to 1. So this is what they've agreed. They've agreed essentially to exchange $100 for 2,000 RTR. So 91 days, party A is going to give $100 to party B, and party B is going to give 2,000 RTR to party A. And so they basically have a hedge here. So if the spot RTR changes in 91 days, so if it's 16 or 25, so it's not 20, but it's 16 or 25, then there's going to be a gain or loss for party A or for party B. So the 2,000 RTR divided by the spot rate of 16 minus the 100 that they initially paid. So this is the amount of dollars they're going to get, minus the 100 that they initially gave up. They're going to come out ahead $25. If the exchange rate goes the opposite direction, 25, then the 2,000 RTR that they're going to sell in the market at an exchange rate of 25. So it's depreciated, right? And so they're going to get 22,000 divided by 25 minus 100. They're going to end up with a loss of $20. Now, the party B is going to have the exact opposite results because they have the exact opposite position. Now, a non-deliverable forward allows actually for the same hedging to go on. That party A and party B are going to get the same net results as they would get having done the deliverable and then selling it. But in this case, the actual selling is going to be built into the transaction. So party A is going to give $100 to party B in 91 days, and they're going to receive the dollar value of 2,000. So rather than receive the exact 2,000 and then sell it for dollars, they're going to receive the dollar value of RTR 2,000, and so their payoffs will be identical. So that's it. Let's summarize with some conclusions. Interest rate parity says that a forward currency exchange can be replicated by borrowing in one currency, exchanged in the spot market, and invested. If forward FX rates deviate from what can be replicated, arbitrage will tend to push the two back together. Now, credit risk may limit the above arbitrage. So if there's counterparty risk on any of the legs in the transaction, then one of the parties need to be compensated for that. And so you can have some difference related to credit risk. Interest rate parity also allows currency to be synthetically borrowed or lent by using the other three sides of the square that we saw. So non-deliverable forwards replicate the economics of an FX forward contract, but settling in one currency. So non-deliverable forwards are allowing you to do what you could do with deliverable without actually delivering. And then finally, NDFs may be used to hedge FX risk synthetically, or to synthetically borrow or lend in a non-convertible currency. So that's it. Thank you for listening.